Today morning, that is October 11th, today morning Pacific Standard Time, like our GCEC, our public site, had an outage. Like we were getting complaints that saying whenever the engineers were trying to upload the GC logs, they were getting HTTP 504 error. HTTP 504 means a timeout. That is when they upload the log, and then after a few minutes, they're getting HTTP 504. The timeout was happening. So then we started looking into the problem, right? So I'm going to give you two perspectives. The first perspective was, so this perspective was very important to understand the difference in between the monitoring and then the root cause analysis, right? So our service is running on AWS, Amazon Web Services. So we are reporting, see, this is what Amazon Web Service, the AWS Cloud Watch, was reporting to us. You can see we made a code deployment on Saturday evening, right? Which is on 10/9, right? We made a deployment. After that, if you see, this is what AWS Cloud Watch is reporting to us. You can see that the CPU is starting to climb up. See, this is that analysis report. The yCrash, what does it do is, when the problem happens, yCrash captures the 360-degree data. It captures the GC log, thread dumps, EB dumps, and then netstat, vmstat, iostat, top-dash, the system level data. And then it analyzes them. And then it immediately generates a root cause analysis report. That it analyzes these dumps and then generates a root cause analysis report. This is what the report is showing. See, for each and every artifact, we see a separate menu items here. When we click on that, we can see the details. But here, this is a summary page. Look at this. In the summary page, right here, it is reporting that 20, see, when you see this kind of red dash cross mark, that means a serious problem. It is reporting right away, saying that there are 20 threads waiting for the response from an external system. It can slow down the transactions, examine the stack trace. It is reporting to in here. So what are those threads? What they are doing? I'm clicking here. When I clicked here, so these are those 20 threads which are being blocked for a very prolonged period, right? So when I look at the stack trace, see, you can see we are running on Apache Tomcat server. So this is you can see it's Apache Tomcat code base coming along. And now if you see here, this is our code, right? The GCEC code. The GCEC code, it is saying there is this called GC report DAO, a data access object, and it is making this call, select report by ID. It is on this line of code, it is making a database call, right? We can see that because of DAO. And from here, it says we are talking to MySQL database. So we see this MySQL call. But all these 20 threads, they are stuck for a long period. They're not getting back response from the database. All these 20 threads were exhibiting the same stack trace. And now that means this call is what the culprit is, right? This is telling me like this line of code is what making all our threads block, right? So now let's look at what this line of code was doing. GC report DAO, line number 335. I'm going in here, GC report DAO, line number 335. You can see, so this is that method. See, you can see here, what is this method doing? You can see it is executing the SQL call. Select star from a GC report where the file path is equal to, they're passing in a parameter, a string, a file path string. Apparently, in production, this GC report table has millions of records. It has several millions of records. So when I do a select call, I now have to scan through all these millions of records to get this result. So that's why, and then it takes time, right? If I'm going to make a lookup, and this is a string lookup, and this has millions of records. So now this, to scan through these millions of records to go and get the result back, it takes enormous amount of time. So during all this time period, the threads are stuck. So then it's timing out for the customer. So now this became clear because this is a new code that was added by our development team. When they do the development, in our development test environments, in our database, we had only few records. So it was going through very fast. This query was going through very fast. But only in production environment, because we have millions of records there, making the SQL call really slowed down. So now, just by looking at this, the yCrash is pointing out exactly, it's pinpointing the exact line of code where which SQL query is causing the problem. So then as an immediate recovery, we commented out that call so that we are no more making call, and then we made a deployment. And right away after making the deployment, the database connections came down, the customer started to get the responses, right? So you can see there are also other elements, right? So when I click here, I can see the GC activity, analyze the GC activity, the thread activity, all those things. The processes, what are the other processes running? We get all this information being presented in yCrash. But this is all good, very good information. But however, the core of the problem was these long-running SQL query. So that was the root cause for our outage we experienced. Any questions from any one of you?
Nora.
Nora.
So is it clear?
No.
Yes.
Okay.
Yes, sir.
Okay, good. Okay, thank you.